first step will definitely we are trying to get the some form of measurements. All right. So that means we want to know. First of all, for example, let's say this is your load cell, and then you have already done all the signal conditionings. All right, so signal conditioning already done, and then eventually it goes to the, let's say it is a multimeter. All right, so multimeter will show what is the value. Okay, so let's say it's a voltage. So regarding the calibrations, actually we want to find a relationship which relates this is a voltage, and then here that is the wave. Right, so the wave will be applied at this load cell. Okay, and because you already have a signal conditionals and connect to the multimeters, and therefore you can easily just try to make certain measurements. You apply a wave, let's say it's a 1 kilogram, and then 2 kilogram, or 1.5 kilogram, and so on, 3 kilogram. Let's say with 1 kilogram, 2 kilogram, and then 3 kilogram, you measure for the voltage. Then later on 4 kilogram. So eventually you are going to get a straight line like this. Okay, so this is the first step. You want to get this graph. All right. Second step will be establish the relationship. All right. So in this very simple graph, you can see that it is actually a linear, and therefore I can just use a y equals to mx plus c in order to get the plottings. But if let's say you didn't get a straight line, but of course in this load cell, supposedly you should get a straight line, okay, because there is a theoretical. What I meant is, if let's say indeed your relationship is something like this, it's non-linear. All right, but load cell, please bear in mind, it has to be straight. It has to be a linear graph. What I mean is, let's say other sensors, and then you found that it is non-linear. So when it is non-linear, most probably you can this is the wave. All right, let's say this is a parameter beta, and this is a parameter alpha. So you need to do some kind of pre-treatment to the results. So instead of alpha and beta, this absolute, maybe you try to get a natural logarithm, ln A and then ln B, ln beta. So in that case, because you are getting a logarithm, this instead of a natural, I mean this is a quadratic or a non-linear, then it will be straight away turns into a linear graph. So in that case, you can establish the relationship as a ln alpha is essentially equals to m ln beta plus c. Okay, so this is what we so-called as a linearization process. After that, we establish the relationship. There is a second step. And the third step will be, now we are going to measure the voltage. Okay, instead of having this kind of graph, now we are going to, based on the relationship, and then try to do the actual measurement. So in this case, we reverse it. This is actually the wave, and now the input will be the voltage. All right, so just by measuring the voltage and relying on this relationship, then we are able to determine. All right, so for example, here I get a voltage which is somewhere around here. All right, and therefore according to the relationship, I should get this wave. Okay, everyone clear? So far so good? Everyone clear about this sort of a setting?
Doctor, can you explain the step 3 again?
Step 3, all right. Okay. Okay, this one. So step 1, I think everyone have no problem. Step 2 also no problem. So step 3, it is actually just like we have already set out all this, everything is ready. So now we want to test the accuracy of your whole system. All right, so far from step 1 to step 2, it is more towards the setup of your instrumentation system. All right. So after you have already set up the instrumentation system, and at the step 3, we are actually trying to determine the accuracy of your instrumentation system. So in this case, we are going to apply some kind of non-load. So let's say maybe again we use a standard load, standard weight. Let's say this is a 1 kilogram. Okay, let's say we are comparing this with another kind of a measurement system. For example, just a mechanical load, right? Something like. Right, so I think you all know this kind of scale, right? We just apply another scale compared to another scale, right? So in this case, let's say in this scale, this load, we put it here, and then we know that this is 1 kilogram. Okay, and then after that, this 1 kilogram I place onto here. This one I place onto here. Right, so I place onto this load cell and the whole system that you have established up to step number 2. Right, so since you apply a 1 kilogram over here, and then what you are going to get is V1, let's say. Okay, so you from your system, it gives you that this is a V1. So that means we know that V1 is here. And this V1, we substitute this voltage into this relationship to determine what is the wave, the corresponding wave over here. Let's say this is the M1. Okay? And then later on, the same procedures we repeat again. Now we add in another, the same wave. Okay, this is, we repeat the same wave measurement. This one, we take it out and then we measure again. We still get 1 kilogram, then we place it here. So from here right now, we get, let's say, another reading, which is a V2. So V2 is somewhere around here. Okay, so doing the same thing, we plug it in, and then most probably is here, and then eventually we get another measurements of M2. So repeat again. So this one will get a V3, and then we put the same weight again over here, and then we get the measurements. Let's say it's a V3, it's somewhere around here, so we get M3. So in that case, we are going to, we will be able to construct a table. All right, so okay. So we could construct a table, which is something as this. All right, so we have here there is a, how is it? Right. So this will be the right. Okay. So this one could be using the sensor A, and then here there will be this one can be using a scale. Okay, we are using comparing between your system and the with another measurements. Okay, so in here there will be this will be the number. So you have a trial 1, trial 2, trial 3, trial 4, and eventually we are going to get this. So eventually, yeah, I think most probably we don't really need to reach up to here. Okay, so several trial, and then in this case you are going to get the sensor one. You measure is a M1, M2, M3, M4. Whereas from the scale, we know that it is, let's say it's a 1 kilogram, 1 kilogram, 1 kilogram, 1 kilogram. Okay, so in this case, you can let's take this scale as the gold standard. And in that case, we can evaluate what is the accuracy of your sensors. So the accuracy will be, maybe you try to get the error. Okay, so in this case, you determine what is the error, and then you are going to get E1, E2, E3, E4. And therefore, maybe you just get the average of this error, and this will by getting the average of this error, you will be able to know what is the accuracy of your system. Okay. Have I explained step number 3? Is everyone clear so far?
So Doctor, just to clarify myself, so we will get a voltage from the sensor, then we will plot into the graph, which will give us the value of M. We will do this repeatedly for a constant weight.
For some kind of a weight, yeah.
Then we can calculate the error using the formula that we already learned.
Error is essentially just the comparison between the sensor with a gold standard. So this gold standard, you may use your kitchen scale that is available in home, okay? Or maybe you just refer to some, for example, maybe you can purchase a 1 kilogram of a flour, or 1 kilogram of rice, 2 kilogram of rice. This is usually already packet. So it means that this is actually constantly you get a 1 kilogram. So in that case, you know that this is actually 1 kilogram. And therefore, you use your system to measure whether is it going to give you 1 kilogram or not. So in that case, you just keep on repeating a 1 kilogram, then you get this set, maybe repeat 4 to 5 times. So you get M1, M2, M3, M4. Then you average. This is actually the average values by your sensor. Then later on, most probably you can change again. Instead of 1 kilogram rice, now you go for the 2 kilogram rice, 3 kilograms, something like that. Okay? Is everyone clear? Is okay, everyone?
Doctor, just one more question. So the usage of Arduino in this system, this project is actually for us to convert the, to show the voltage output, right?
Yeah, just actually Arduino for me in your current, in this project, the main use of Arduino is just like a multimeter. All right. So if let's say you don't want to use Arduino, then you just go and get a multimeter to do the measurements. It's also the same thing. You want to get the voltage. The only thing is when you are using the Arduino, one good thing about it is that you can measure the voltage at 5 different sites concurrently. You can straight away measure 5. Multimeters, you can only measure 1 point. Whereas for the Arduino, it can measure 5 points concurrently. Okay, so you may use Arduino or you may use multimeter. And the main reason I recommend you to use Arduino is just simply because you can still use this Arduino later on in the mechatronics. Okay, in the following semester, I think some of you will be taking mechatronics as well. So that means you are not going to buy multimeters this semester, and then next semester multimeter most probably is no longer used. You still need to buy the Arduino. Okay, but if let's say you still want to like make your life easier, then you can go for the multimeter lah. Okay, have I answered your question?
Yes, Doctor. Thank you.
All right. Okay, any more questions? When is the due date for the project? Of course, there will be the before final exam. All right, final exam, I'm not sure when is the date, but it should be somewhere around January or February, right? So actually, we are quite running out of time already. So make sure you all should start the project. At least you should start purchasing the components. Okay. Okay, as for the gold standard, the way for the gold standard, there are several ways of getting this done. So in your report, make sure you mention how you decide the gold standard. So the gold standard could be, one approach is you use a scale. Okay, a scale readily available in your home. So for example, like the kitchen scale. So that means you have another mechanical scale that is able to measure the weight. So in that case, you can use any of a wave, right? So for example, you get some kind of wave, and then you don't really know what is this wave, and then you measure using this scale. Then in that case, you are able to determine what is the wave over here, right? And then later on, you can compare with your sensors. Okay, this is one approach. Another approach is you purchase those readily packed products. For example, you have a one pack of rice. It could be 5 kilograms or 2 kilograms of rice. Okay, or maybe 1 kilogram of flour. So this is a standard weight, right? You may purchase the flour or purchase the rice. So in that case, this actually it will not be so much burden to you all, because the rice you can still eat it. Okay, but if let's say you have some money and then you want to purchase, you can also purchase standard weight, right? For example, a dumbbell. This dumbbell actually have a 5 kilogram. So this is the kind of a wave that we know, and then you can just use it and then measure using the log scale. Okay, using your sensors. All right, so far everyone clear? Is that all right? Everyone, is that okay? Any more questions?
So far, so good.
So far, so good. Okay. Just that one thing I need to remind you. You need to design the measurement system. Okay. So what I mean is something like this. Because I'm not sure whether did you recognize this or not. All right. Something like this. Okay, you can see the website, right? Everyone, could you see that?
Yes, Doctor. Yes.
Okay, so what you are going to purchase will be a load cell that looks something like this, maybe. Okay, but if you have a look on this load cell, how can you load it with a 1 kilogram of rice, let's say? Did you see that? This is load cell. but you need to have a mechanism where you can place that 1 kilogram of rice on top of it, and then you can load this load cell, and therefore you can get the measurement. So that means you need to design some kind of a mechanism or apparatus. So for example, that looks something like this. Okay, you can see that this is also a load cell. So you are going to screw it to a plant, for example. Okay, and then later on, here this is some form of an empty space, and therefore you have a place for you to hold that 1 kilogram of weight. So 1 kilogram of weight will be applied onto this side, and because this is actually screw and fits to here, so that means this is this load cell is now performing just like a beam. Okay, it is just like a beam, and therefore the load cell on top will be experiencing tensions, and for the load cell at the bottom, it will experience compression. Okay, this is one type of mechanism. It could also be a design that looks something like this. This one actually no. Let me see. Yeah, for example, like this one. So you are going, you may also put your load cell that is like this, and then on top of here you design a place, a rack, all right, and then you place on top of here. So in that case, you apply the load, all right. So once you apply the load, this causes the load cell to be a shear type. So it means that all 4 strain gauges will be experience the same tensions or compression force once you apply the load. So if you apply the load, then this is most probably a compression. Okay, all 4 will experience the same compression. So this is a shear type. But basically, your load cell looks something like this, where you have a kind of hole over here. This expects you to load it using through the beam type. Okay, it's a bending type of a load cell. So make sure your design should be reasonable. Don't make it into the form of a shear type. Okay, I'm not sure whether do you understand what I'm mentioning, or what do I mean over here. Did you get that? You clear? Okay. So for those who understand this, and then if let's say later on your friends actually having troubles on this, I hope that you can share the information with friends. No matter, because we actually doesn't have any groups. So make sure if you have any questions, just discuss with your friends. But you may share the same idea, but don't copy exactly. So it means that during the constructions, you may have the same design, but most probably the construction will be different. One may be using the wood, and then other will be using the PVC or whatsoever. So I expect you all to use different materials, right? Rather than all are using the same materials. So this is definitely a very clear indication that plagiarism actually happens. Okay. So you can see that when you purchase the load cell, basically it looks something like this. But how are you going to load this load cell? All right, you have a packet of rice, and then how can you hand this rice onto the load cell? This mechanism, you need to design it. Okay, supposedly everyone should have different design, but if let's say you all have the same design, then most probably make sure your fabrication materials or the size of your design will be different from person to person. Okay, everyone clear?
Doctor.
Yep.
Sorry for asking this. Just to, I'm just curious. For the previous that you teach us to get the V versus weight graph.
What do you mean? B versus wave?
Yeah, voltage versus weight graph.
Oh, okay. You mean the calibration just now?
Uh,
All right.
Actually, if we are just getting the error in step 3, how we are going to produce in step 1 actually? Or we
Step
just
1. Okay, so step 1, it means that this wave, it has to be standard wave. You still remember just now, I mentioned the standard wave could be 1 kilogram of rice. Okay, so you just hang 1 kilogram of rice at the load cell, then in that case, you are going to get this reading. And then 2 kilogram of rice, then another readings. 3 kilogram of rice, another readings. Okay.
so where the weight we are putting on here will be scaled in a scaler, right, doctor? Not the sorry. How
You
to say
mean
this?
the scale?
That means like the gold standard, right?
It has to be standard.
Okay,
So
okay.
it has to be known weight, right? A weight that you know what exactly is the kilogram. So in that case, because you know the wave and then you plug it here, then you get the readings from your Arduino or multimeters, then you get the voltage. So you, in that case, you can get this kind of plottings. Okay, but of course, you can also repeat this process several times. So in that case, most of you will get this and get this and get this and get this. And in that case, you can average it and then eventually come out with these lines. Okay, so this is just a statistical analysis part. So how to use it, this one I leave it to you. All right, and then later on in the step number 3, this standard or known wave, actually you can reuse it again, but this round you do it in the different way. You load it to the load cell and then you measure the voltage and then you get the readings. Okay, so it's just like we are from here, you are doing from A to B, and in the step number 3, you are doing from the B to A, something like that. Okay, have I answered your question?
Yes, the first one is from the gold standard to the voltage, and the third one is like we are just putting a weight and we are getting the mass, right, doctor?
Yeah. So it's just reverse the
All right.
reverse the procedures only. But of course, in real life, the standard wave that we are using it to measure, I mean, to standard wave use the step 1, shouldn't be used again in the step 3. So in the step 3, in the real life, most probably will be using some kind of unknown mass, right? And this unknown mass and will be measured using another scale. So this scale could be a mechanical scale, but at least it's a gold standard. It's a gold standard scale. So that means we are going to compare 2 sensors, comparing your sensors with another sensors. Okay, this is in real life. If let's say in the industry, then we want to determine how accurate is your sensor, then you need to compare with the other sensors. Okay, but of course in this project, we can simplify it. Okay. So how do I get the 0 voltage again after we put the platform on the load cell to measure the wave of rice, for example? You mean how to adjust the Wheatstone bridge in order to 0 the voltage? Is it, Danish? All right, so in that case, for this load cell, I think most probably you won't be able to 0 the voltage because all those Wheatstone bridge, okay, we know that this Wheatstone bridge, it actually is something like this, okay, and all of them already attached with the load cell. We have 4 load cell, And therefore, if let's say one of the load cell actually is a malfunction or actually doesn't have the identical resistance, then most probably you are not going to be able to change it. All right. So in that case, I don't think you will be able to zero the offset voltage using this Wheatstone bridge, because you cannot change the load cell. But in real life, of course, you can change the load cell. So most where you found that load cell number 4 is not accurate, then most where you can take it down and then you attach your own load cell. But in this project, we are just using the load cell that directly purchased from the internet. So that's why I don't think you will be able to balance the Wheatstone bridge. Okay, so in that case, even without, I think you don't really need to offset the, the zero balance. You don't really need to nullify the bridge, by the way. So eventually what you are going to get will be something like this. So it means that your linear graph will have some kind of an offset. So in that case, you are going to get a linear graph with the offset C. That's all. Okay, so that means later on when you are doing the reverse, you just use these formulas, the same formulas, and you try to rederive for the x. It will be something like the y minus c and then divide by m. Okay, so this automatically will get rid of that offset, the effects of the offset. All right, have I answered you, Danish? You clear? Okay. All right. So any more questions? Any questions that you, yeah.
Sorry, just to reconfirm, the load cell that we purchased, we already have the Wheatstone bridge, right? Like we just connect it in a Wheatstone way, so we don't need to add some more resistor like that, right?
Yeah, no. Actually, if you take a look on the load cell and then I think the Wheatstone bridge. Maybe. No. Load cell and then pin out. Yeah, something like this. Okay, let me share the screen. Okay. All right, so you can see that for this load cell, this is the wiring diagram. So output from your load cell, there are actually 4 cables, and these 4 cables have it has a colors red, green, black, white. Okay, so red is essentially here. All right, so that means if you have a multimeters and then you measure the resistance between the red cable and the green cable, most probably you will be able to determine what is the resistance for this load cell. The strain gauge. Okay, strain gauge number 2. And if you want to measure the resistance for the strain gauge number 1, you can use a multimeter, measure between the red and this one is white. Between red cable and the white cable, you are measuring the resistance for the strain gauge at the first strain gauge. Third strain gauge, you can measure the resistance by measuring between white cable and the black cable. Okay, so that means because your load cell actually already placed the strain gauge in the Wheatstone bridge, already in the diamond form. So this is definitely a full arm bridge. So you cannot change the resistance anymore. It is totally dependent on the strain gauge. Okay? Clear?
Clear, Dato'. Thank you.
All right. Ahmad Isan, you ask, do we need to minus the voltage change from the wave of the platform to get the real known wave of our rise? Okay, let me try to figure out what is your meaning. Do we need to minus the voltage change from the wave of the platform to get the real known wave of our rise? I don't really understand what do you mean actually, because voltage and the wave I think is two different dimensions. You cannot directly minus it unless the voltage change you convert it to the wave through the calibrations, and only then you can minus. So basically, if let's say in the step number 3, you are comparing your sensor measured weight. You use a sensor and then you measure the wave is equal to M1, and then you compare with the real wave, right? That is coming from the rice packet, which is our standard is 1 kilogram. So in that case, you found that it's different. So this is considered to be error. It's no longer you can I mean you add back that error back, and then in order to make your sensor more accurate. So it is not the case. That is already considered to be biased. All right. So if it is already in the step number 3, and you measure that there is an error, there is a difference between your sensors mass readings with the gold standard max. So that means this is the error, and this error is after you get several measurements, let's say 5 or 10 measurements, repeated measurements. So the maximum error will be reflecting the accuracy of your system. Okay, so I'm not sure whether have I answered your question. So if I didn't answer, maybe you can open your mind and then ask me in for greater details, because I don't really understand what is your question. Okay, Ahmad Isan, is that okay? All right, Ahmad Isan, is that okay? Any updates from you? All right. How about the others? Any more questions? You may just ask me whatever kind of a question. Even if you don't understand the project, just ask. Because this is a time for us to have a free discussion, so that you ask the questions, the others could also learn from your questions.
Doctor.
Yeah.
I have a question. For the load cell that I purchased, they already have some specification under the load cell. It's telling that it has a 0.1% full scale error. I think so. What they mean by the specification, but if that is the case, should I apply that full scale error in my calculation also?
Okay. That the load cell that you purchased, it mentions that it has an accuracy of 0.1 full scale, is it?
Yes, but that's as per the online.
Okay,
shop.
that is because they have tested their system with that HS711 driver. You still remember? And
yes,
because we are developing our own signal conditioning system, so most probably your accuracy will not be as good as that HS711. Because HS711 it will have faster readings and then more accurate measurement, something like that. So in that case, if you let's say you use that accuracy in your calculations, then most probably could not reflect the actual situations. We are doing it starting from the scratch, from the background. So that's why I believe your accuracy will not be able to reach that level. Okay, this is one thing. And secondly, those accuracy or the characteristics that is mentioned in the catalog or specification is just for your reference. It is conducted in the control environment or in in a most ideal way. Okay, it's the most ideal situations. But in real life, even you use HS711, most probably you won't be able to get back that 0.1 full scale accuracy, okay, as stated in the catalog. The main reason is that the way you do the connections. For example, the load cell, you have 4 pin, right? When you solder it or you screw it to a terminal, the connections of your load cell with the HS711 or even the wiring, this by itself will cause a slight resistance change to the load cell. So those that are listed in the catalog is just for your reference. So the main use of it is you can compare with the other system or other load cell to determine which load cell is more accurate. That's all. And then later on, once you get that load cell, if let's say you didn't follow their instructions of soldering and also the wiring connections, most probably you will not be able to get that accuracy as well. Okay. So have I answered your question? You clear?
Yes, okay, yes.
Okay. Already bought the parts, but still kind of lost where to start. Okay, you already got the parts, and now most probably you can just try out with the, first you try out with the differential amplifier. All right. So differential amplifier, you can try it out, actually simulating it with the Tinkercad. All right. So I think I'll just all right. So I'll just assume that you have already obtained your parts. Right. So let's say you have already obtained your parts. What you need to do, first, try to design your differential amplifier. Okay, so this one you can actually do it in the Tinkercad. So the wiring and also so that means you are going to the circuit is something like this. Have I missed out something? Yeah, here. Okay, so this is a circuit for the differential amplifier. And in the Tinkercad, try to familiarize yourself how to play around with this resistance R1, R2, R3, and R4. Okay, just familiarize with yourself. So for example, like the battery, how are you going to align the battery, the positive and negative? All right, and then in order to get the positive and the negative supply. This is the first thing that you need to familiarize yourself with. Okay, and once you are, for example, in the first step, you will try in the Tinkercad. And the second step, again, is the differential amplifier. But this round, you try the hard way. So it means that you plug it in the breadboard, and then you do the connections. Because the hard way, I'm not sure whether you are using what kind of op-amp. You may use TL074 or TL072, or even the most classics, most probably is U741. I think it's UA741. It depends on the factory. So these terms could be different, but basically the numberings behind should be the. So most probably is a UA. UA, I think it is manufactured by the Philips. Right, so it depends on which companies. If let's say it's made from the Texas Instrument, most probably you get LM741. So depends on which factories that you purchase it, but basically the 741. So there are also several other types of op-amp. I'm not sure whether which one are you going to select. Okay, but anyway, based on your hardware, and then you check your specifications, and then later on you just put it on the breadboard and try to see whether the wiring in the hardware is it functioning. Okay, so that is a second step. Okay, so far everyone clear how to start? Danish? Clear? So far clear up to now? All right. So once you have performed the second steps, the third steps will be now you are going to integrate. Or maybe before this, maybe you can start. Okay, or maybe the third step you play around with this the load cell. Okay, so for example, maybe you use a multimeter to measure the resistance. All right, so you may try to bend it a little bit, and then you see what is the resistance change. Okay, so you can play around with this load cell. And then, or maybe if you are using the Arduino, then you have a load cell. This is already in the diamond shape, and therefore you just apply power supplies to here as shown in the pinout. Okay, so maybe here you plug a 5 volt or 12 volt or whatsoever. But if you are using the Arduino, then most probably you can okay. So most probably you can just draw the 5 volt from the Arduino board, and then later on you just get this and this, and then you plug it to the analog input or analog input 0 and then analog input 1. So you measure the voltage and you try to get this one, let's say give you the V0, and this one give you the VA, and this one give you VB. Then therefore you can, in the Arduino, you just get the VA minus VB, and observe by bending your load cell, are there any voltage change? But of course, this voltage change will be very small. But I think Arduino still will be able to reflect the change a little bit. So by bending it, most probably you can see that there is a slightly changes to the value measured by voltage A or voltage B. So this one is playing around with this load cell, just for you to get familiarized about how is this load cell is about. Okay, so the fourth step will be you integrate your load cell with this differential amplifier. So in that case, you may just try to measure because differential amplifier, you will be amplifying it, and therefore you just measure the voltage output from this differential amplifier. Okay. So lastly, after you have integrated and all these differential amplifier, but of course, here, because in the step number 3, you can slightly have an idea how small is the value of this voltage. Then you may now to decide what should be the gain. All right, the amplification gain for this differential amplifier, is it 1,000 times, or you need it to be 10,000 times, or just 100? But most of the design, because it is desired that the range of the resistance should be from the 1 kilo ohm to 1 mega ohm. So the highest amplification gain for one amplifier is actually just 1,000 times. Okay, that is 1 mega ohm divided by 1 kilo ohm. Okay, you get a 1,000 times. So if let's say you want to achieve amplification gain more than 1,000, most probably you need to cascade to. So here we have this differential amplifier, and in that case, most probably you are going to cascade it with another op-amp, the inverting amplifier. Okay, so in that case, you can achieve a larger amplification gain. Okay, so that is step number 4. You integrate it, and after you have gotten this step number 4 done, then the 5th will be the calibration. So calibration, as I mentioned earlier, first establish the relationship, and then second step, establishing the relationship. So this one will be we have a known wave, and then we try to measure the voltage. So in that case, we are going to get voltage will be equals to the slope, and then multiply by the wave, and then we sum offset. Okay, and then later on, once we have already gotten this relationship, and the second step will be what is the second step already? Okay, the second step is actually trying to establish the relationship. Okay. So to establish the relationships, most probably you can use a statistical approach as well, right? So statistical approach meaning that you can get several readings. Okay, so in this case, you can get several measurements. Most probably you are going to get this and this and this. So in that case, you can most probably use a regression analysis. Regression in order to get the relationship. I think in the Excel, when we plot the trend line, you still remember? So that is how we can get the regression line, okay, using the trend line in the statistics. So in that case, actually you are going to have some kind of a confidence level R square. So how confident are you that this data could be fitted with a linear line, with a parabolic line, or something like that? Okay, I believe you have when you try with these Excels, and you should know that. Okay, that is the second step, and the third step will be the testing. This one will be the accuracy testing. So accuracy testing, in this case, we are going to measure the voltage and then getting the wave based on this relationship. And of course, we are using some kind of unknown or standard maths in order to do the testing. Okay, so these are all the steps that you need to know in order to start to carry out this project. Is that clear, everyone?
Doctor, we can use any op-amp, right, for this project? Any combination of op-amp?
Op-amp, for example?
For example, I thought about using a voltage follower, then non-inverting amplifier.
Yes, this one, the op-amp circuit, you can use it. Whereas for the Abdurrahman Abad, you get op-amp LM358. So LM358, I think I need to check, because there are 2 types of op-amp. One is a single supply and another is a double supply. So LM358, let me check. All right. Okay, for LM358, let me share the screen. Where is it? Okay. So let me search for the LM358. So you can see that this is a LM358 pin. And if we have a look on the pin out, so one indications of it. LM358. This one is too small. All right. So you can see this one, right, everyone?
Too small, doctor, actually. Now can see a bit.
Now can see. So LN358, you have pin number 8 is connected to the positive power supply, and pin number 4 is connected to the ground. So that is the main issue with this LM358 is that it is actually expecting single supply. Okay, it's a single supply op-amp. It will be different. I mean, the wiring will be different from what I have told you previously, using 2 battery in order to get that. Okay, so I won't recommend you using LM358 because it's single supply, and therefore in that case, most probably you need to offset your voltage rather than at the 0 volt. So now you are going to offset maybe to 3 volt. All right, let's say your all of the batteries actually give you a 6 volt. So that means you need to offset your voltage up to the 3 volt. So 3 volt will be your reference of virtual ground. And ground will be 0. And the ground essentially will be, in the meanings, will be negative 3 volt. So in that case, this may cause confusion to some of you. And therefore, unless you are pretty sure that what is the meaning, then you can use LM358. But if let's say you are still new and then not very sure about the meaning about this ground, positive or negative, then most probably I think you better just follow what I have taught in the lectures, using the 2 batteries in order to get the positive and negative power supply. So in that case, it's better for you to get the op-amp which is dual supply. Okay? Is that all right, Abdul Rahman Abad? Yeah, so you can use LM358 actually, but the problem is that I'm not sure whether are you going to be able to handle that, because the perceptions on the ground and the positive and negative will be different for the single supply op-amp. Okay, you need to offset it. So that is the problems. I'm not sure whether you can handle it or not. So I would strongly recommend you use dual power supply op-amp like TL072 or TL074. Okay, 72 meaning that it has 2 op-amp. 74 it will have 4 op-amps. So essentially all are the same. They use positive and negative power supply. Or 741 only 1 op-amp. Okay. So any more questions? Actually, I have a lot of things that maybe I'm not sure whether you all understand or not. So that's why I would rather you ask me the question, because some of the knowledge for me I think is too simple or is basic, but for you maybe it's very difficult. So make sure you ask, even you feel that the question is very stupid or is dumb to ask this type of question. But for me, maybe it is very simple. But for you, especially a mechanical engineer students, it could be a very tough question. So any question, just ask, please.
Doctor, for the Arduino programming, actually I don't have really a good understanding of the Arduino programming. For that, anything that you can give me a clue on it?
Okay, Arduino programming, you don't have to worry about it. Basically, you know how to upload the program to Arduino?
From the previous Tinkercad demo, I think I can.
No. I mean, in the real life, you have the Arduino board and then connect to your computers. This one, you can set it out already. Basically, you just install the Arduino IDE then all the driver should be readily installed. And therefore, once you have installed Arduino IDE, then you just plug to your computers. It's already working. Okay, unless you purchase the Arduino Uno board, which is made from China. So if it is made from China, make sure you also install a CH340 that USB driver, because China Arduino Uno board, it use different USB driver. So you need to install that USB driver. Once you install both the USB driver CH340 and also the Arduino Uno, Arduino IDE, then you directly plug your Arduino to your computers, then it is working. Okay, so do you need me to explain this to you? Because for me, it's actually common knowledge, but I'm not sure about you all. Do you want me to explain it? How to install the driver?
Can, Doctor.
Yes, Doctor.
All right. Okay, this one I think I also overlooked it. Okay, let me search for the driver. Okay, all right. So the step is something like this. Wait, let me stop sharing. This one. All right. Okay, this one, and then goes to here. All right, so you can see that this is the page. First of all, you go to the Google. All right, in order to install the Arduino Uno. Okay, before this, maybe I'll just Arduino Uno board. Okay, so now let's have a look on this figure. You can see that Arduino Uno could have many kind of design, right? So if you see this kind of a board with this infinity logo, this is the copyright board, or this is the the original board. Okay, originally coming from the Arduino. But of course, this board is very, very expensive. It could be somewhere around 70 or 80 RM. Okay, so most of the time when you are purchasing in the Lazada or something like that, most probably you are going to get a board that looks something like this, where you have a Uno, all right, and then it doesn't have any logo with the infinities. It just have writings Uno, or maybe something like this Uno R3. Okay, R3 just means that it's a release number 3. Okay, so, or maybe even instead of getting the blue color, you are getting okay, let me China made. So especially when it is made from China, you are going to get the Arduino Uno board in many color. Okay, I couldn't find it. Okay, maybe I get a yellow. Yeah, so you can see that this is also Arduino Uno board. It's just that it is in the yellow PCB. All right, so for example, this one, you have a Uno R3. This is actually China board. It's for sure China board. Right? It can be in the yellow color, or it can even in the purple color or black color. For example, like this is a black color. All right. So China board, it could be also be in this blue color, but it's definitely different from the original board, which is in the green blue color and then with an infinity logo. This is the original board. Okay. So right now, what I'm mentioning here about I'll be totally focusing just on the China board. Okay, because it's the cheapest one. Usually the price for this China Uno board will be somewhere around 15 RM. Okay, that is I'm not sure. This I actually checked this price quite a year ago. So maybe right now it's even cheaper. So it's up to you. As long as if let's say you get the board, Uno board, which is having the price range of 10 RM to 20 RM, then most probably this is a China board. So when you are using the China board, first of all, you need to install the library. I mean the CH340. You go to the Google and then you type CH340 driver. Then straight away, yeah, how to install CH340 drivers. So there are quite a lot of this entry over here. Okay, so you can see that this is all right. I think maybe instead of typing this here, maybe just Arduino. All right, so Arduino CH340 driver, you just try to search for it. And you can actually goes to, for example, this any of this. Let me see. All right, just try to search for the driver. Yep. Okay. Yeah, CH340. Yeah, and then you can see that maybe you can go to this website like Electropic. So you can see that even here it already give you the link, and therefore you just follow this step. First, download the driver. Second, install the driver. So you are going to get, so you press install, and then once driver install success, you are going to get this. And eventually, after you have installed this driver, okay, and then now you goes to the, okay, again, go to the Google, and then you type Arduino IDE. Okay, so the website is usually www.arduino.cc. So you just select this Arduino, and then you can download this IDE. The latest version is 1.8.19. You can install download the Windows. Okay, so Windows 7 and newer. So you just click this one, and you will ask whether do you want to donate or not. So basically, you can just directly click just download. Like if let's say you don't want to contribute or donate the money, all right. So it's free. You can just download and then use it. Okay, this is a freeware. You just download, and then once you download it and then you install it, and towards the end, it will ask you, do you want to install the USB driver? You just say yes. Okay, install the USB driver. That's it. Okay, so these are the two things that you need to install. One is the CH340 driver, and another is the Arduino IDE. Once you have installed these two, then you can connect your Arduino to your computers. And once you connect it, and it will be looking something like this. Okay, so checking if the driver installation is it correct. So you can see that once you plug in your Arduino Uno board to your computers, you should get this at the device manager. And here you can see that there is a CH340. This means that your CH340 driver has been properly set up. Okay, and your Arduino Uno board is connected to COM7. Okay, all right, and then later on when you want to upload the program, then make sure that this is Arduino IDE. You open now the Arduino IDE, and then this is the coding, and you just go to tools and go to the go down port and then select the COM. Just now it has been connected to CH340, is connected to COM number 7. So here you just highlight that it's COM number 7. But most of the time, because we don't really use a lot of a COM port, most probably in your PC, you have only one COM port. So you just select it. Just highlight that this is the COM port connected with your Arduino IDE. Then later on, you just press these buttons. There is an arrow buttons. You just click it, and then you can upload the code to your Arduino. That's it. Okay? Is that okay, everyone? now understand how to set up for the Arduino?
Yes, okay, but need to try first.
Yeah, you need to try, but basically the idea is that you need to install CH340 first. For if let's say you are using the China driver, the China board, and then later on you need to install Arduino IDE. These two is a must. You need to install these two first so that your computers can detect your Arduino Uno board. All right. Once your computer detect Arduino Uno board, so that means you can now start with the program. All right. So for the programming, in your project, because you are only just measuring for the voltage, so that means you just use the code. Very simple code is already enough, right? Okay. I think let me just show you. Okay, I just share the window. Not window. Okay, share the entire screen. All right, so you can see that right now is actually in the screen. This is the this is actually the Google Meet. So once you have installed your Arduino IDE, actually it will be appear somewhere around here, right? So this is Arduino IDE, the icon. You can just click onto it, and then you will open up this Arduino IDE. All right, so you just wait for it for some moment, and then it will open up this Arduino IDE. And this is the previous, usually if you have already drafted a program, then it will show the previous program, right? So you just need to go to the file and new. So supposedly you should get something that looks like this, okay? Which is just a blank program, right? With two functions. There is a setup functions and also the loop functions. Okay, so for your project, basically it's quite simple. You don't really need to write the program yourself also because it's already in the example. So to retrieve this example, you just go to File, Examples, and then go to the Basics, and then go to the Read Analog Voltage. Okay, you just open up this example, then you can close the previous sketch, and then you will look something like this, the program. Okay, you can just straight away use this program already. You don't really need to write the program yourself. Okay, so maybe you just need to modify a little bit because this one it only reads for one port, and this port is connecting to the, your analog voltage. Your voltage should be connected to the pin A0. Okay, so that's why here you have an analog read A0. If let's say you want to get a readings more than one, then most probably you just need to duplicate this command. All right. So here maybe sensor value 1 and this is sensor value 2. You just need to modify a little bit. And therefore, analog read this pin port A0. So most probably you are reading port A1. Okay. So in that case, you just duplicate all these commands. So this one float voltage 1 is equals to this sensor value 1 times all this, and then in that case, for the second reading, it will be float voltage 2. It will be sensor value 2 times this. Okay. So if you have more, then you may just duplicate all this, and then you have a let's say I want to get 3 readings at the same time, so I'll get a sensor value 1, 2. This will be 3 analog read. So now port will be A2. So for Arduino Uno, it will have the port that can be used to measure the voltage. It is actually extending from port A0 to A5. I'm not mistaken. All right, let me check Arduino Uno. Arduino Uno, yeah, pin actually, yeah, A0 to A5. Yes. So you can actually measure 6 voltage at the same time. Wait, where is it? Okay, here. All right, so here you can just select whichever the ports that you want to measure with the voltage, then you can just duplicate everything. So here float and then voltage 3, and this is equal to sensor value 3, and then times 5.0 divided by 1023.0. Okay, so in this case, you are going to get 3 readings. And eventually over here, print out the value that you read. You can actually write something. This one, maybe it needs you to do some programming. So just serial dot print. Most probably you get voltage 1. Okay. And then serial dot print. Here you just get some empty space. All right. And then serial print, and then voltage 2, and then also some kind of empty space. Right, so eventually serial dot print line voltage 3. So this one, serial dot print line, usually it is used for the printing for the last variable. Okay, and it indicates that this will go to the next line. So in this case, it will print voltage 1, voltage 2, and voltage 3 in the same line, but separated with empty space over here. Okay, so that is the coding. Very easy. You don't really need to develop it yourself. You just put it in. Okay, so far, everyone clear? Is everyone clear about? Yeah. Clear. All right. So for this program, if you want to upload it, make sure you go to the tools, and then later on over here at the port, you need to select the COM port. Because right now I didn't attach with any Arduino, so that's why port over here is empty. Once you attach it with the Arduino, and supposedly there should be a place where you can select which COM port you want to use. Okay, once you select it, then you can press this upload button. All right, so there is the arrow over here. You just click it, and it will compile this code, and then later on upload this program into your Arduino, and that's it. Okay, and to get the readings, you just need to go to the tools. All right, and then later on you go to the serial monitor, and because right now it's actually not okay, maybe you give me, we take a break, and then I try to demo to you, all right, a little bit about how to use this one. Okay. Just take a break for a while. Okay, so everyone, are you ready? Everyone, is that okay? Are you here? All right, so I'm going to demo to you how to use the Arduino Uno. Okay, and let me show you how is my connections for the Arduino Uno. All right, let me open now the Tinkercad so that I can show you the circuit. All right. Okay, so this is the Tinkercad. What I have actually set out is something like this. So I have a Uno, and then later on I get a breadboard over here. So what I did is I just connect this 5 volt, all right, to here. All right, so this is I just put it as red color, and then for the ground, okay. So for the ground, I just connect to here. And then later on, I get another potentiometers, which is this one. I plug it to here. Okay, so in that case, this one is connected to ground, to the 5 volt. And then later on, this another pin, I connect it to the ground. And the middle pin, I connect it to the A1. Okay, so A1, that is for the potentiometers readings. And then later on for the A0s, I try to measure the voltage at the 5 volt. Okay, so for the A0, this one I measure it the 5 volt. And for the A2, I measure the 3.3 volt. Okay, I just do the connection something like this. So far, everyone clear? Okay, so for the coding, okay, text. Right, so for the coding, I will be just using the one that I have developed just now, exactly the same. I'm going to get 3 readings, and therefore I just attach it. This is the code that I'm going to use. All right, that I have copy and paste from the Arduino IDE just now. Okay, so far, everyone has any issues about follow up, understanding what I'm trying to do? Everyone clear? Okay. So for this simulation, definitely I can just run it, and then you can see how is the response. All right, so the serial monitors, where is the serial? Okay, this is the serial monitors, and you can see that I get readings which is something like this. Okay, so I'm going to get 3 readings, 5, 5, and 3.3. So why 3.3? Because the A2, right? You can see that A2 is actually getting the readings 3.3. Okay, A2 is getting 3.3. A1 is the readings by the potentiometers, right, which is in the middle. And then the left one, the 5 volt, this one is the power supply 5 volt. A0 is connected to the 5 volt. So I'm printing A0, the voltage one first, and then followed by the potentiometer. So now if let's say I change the potentiometers, you can see that the values, the voltage readings in the middle will be changing. And the other two, the left and the right, is still remaining the same because it is a power supply. One is 5.50, one is 5 volt, and then one is a 3.3 volt. Okay, so that is how this is the simulations. And now I'm going to show you the hardware. Okay, so all right, so now let me show you the entire screen. For the hardware, I'm now going to switch on. I mean the plug the USB, the Arduino board to the USB. All right. Once you plug in the USB, you should hear that USB connection sound. All right. So how am I going to be certain that this board has already been connected? So I may just go to the okay, right click on this Windows Start button and then goes to the Device Manager. Okay, so it will bring out this Device Manager dialog box. And then I may just go and then switch. Okay, so it seems like this is not connected. All right. Okay, so you can see this USB serial port is not. There is some issues over here. Okay, because I'm using the Uno board by Cytron, so that's why supposedly it shouldn't be using the CH340. But never mind. I think I'll just install the CH340 driver. Okay, so exactly like what we have done just now. Go to the Electropic, and then later on I'll just download the driver. Where is the driver? Okay, this is the driver. Okay, so CH341 SER, so I just download it. Okay. So the connection is a bad connection. Let me see. Download, and this one. Okay, never mind. So I'll just go to another site. Let's say this one, Arduino.eu. So, okay, let's go for this driver. Right, so yeah, I already get the zip file. Okay, so this zip file in the download folder, I just need to, okay, so pull it to the desktop, let's say. Get the folder, this one. Okay, this is a zip file, and then I unzip it, extract here. Okay, so there is the driver, and I just press the setup.exe, and then just install. Okay, so the driver is successfully installed, and then later on, let me see. So now if I plug it in, okay, and then I go to the Device Manager. Okay, so you can see that here I already have the COM port at COM number 8, but why there is no CH340, I'm not very sure. But anyway, so now my driver is already successfully installed, and I can now go to the Arduino IDE that I have previously written over here. Okay, so you all could see the screen, right? Am I sharing the screen? Yeah. You all could see the screen for the Arduino IDE, right?
Yes, doctor.
Okay, so now let's go to the tools, and you can see that after I plug in, so now here it appears COM8. So I need to tick this COM8, all right? And with this program, I just now you can see that. Oh wait, okay. because previously I'm programming another board, not Arduino. So that's why I need to select the exactly the board. So I need to go to here and then select Arduino Uno. This is Arduino Uno. Okay, this is something extra lah. But if let's say you are the first time using this Arduino IDE, then most probably it won't be any issues. All right, so this is a Arduino Uno board. Okay, I already selected, and then port is actually COM number 8, and now I can do the uploading. Okay, I just press the upload, and it will first compile the sketch, this program. So we just give it a moment, and then later on, after compiling, it will be uploading. Okay, so it is uploading, and we wait for some times. Okay, so once it is done uploading, and now we can start with the getting the readings. So to get the readings, because I display the voltage in the serial monitor, so I just go to the tools and open up serial monitors. Okay, so for these serial monitors, one thing that you need to be sure is that because in the program I've write the serial.begin is 9600. So make sure that your serial monitors over here, this baud rate, right? Because previously I'm using another board, so that's why I can use I use a higher baud rate. So, but this Arduino Uno usually by default is 9600. So you need to change it to 9600. Once you change it to 9600, then straight away it will give the readings. Okay, so here you can see that the left side is connected to the 5 volt power supply. It is quite close to the 5 volt. I get 4.99. And for this side, the right side, I connect to the 3.3 volt. I get readings also quite close to this 3.3 volt as well. And the middle is the potentiometer. So now I'm going to adjust the potentiometers. And you can see that once I adjust the potentiometers, I get the readings, which is decreasing. Now it is increasing. Okay, so that is about using the serial monitor. If let's say you don't want to have to see this in the serial monitors, then most probably you can go to the serial plotters, right? So you can see that this is the serial plotters, and I just need to make sure that it's a 9600 baud rate, right? So I have 3 readings. Okay, so the blue line is for the 5 volt, and then another is this one is a red. I think it's a potentiometers. The green is the 3.3 volt. So now if I adjust the potentiometers, you can see that the reading is actually is increasing, then getting the 5 volt. Then I just keep on decreasing it, adjust it, and eventually it will reach to 0 volt. As for the others, it just remain constant at 5 and 3.3 volt. Okay. So that is how to get shows the readings in the serial monitors and also the serial plotters. Serial plotters, you just write something like this. You can already plot it into the form of a graph. All right, that's all. Any questions about this demo? Everyone, any questions?
Doctor, for the serial plotter, I don't know whether it's a thing or not, but can we use it to form a graph for our project?
No.
Okay.
Serial plotter, basically, you can see that the x-axis and the y-axis. All right. So x-axis is the time. Basically, I cannot say it to be a time. This is actually a sample readings. It's a bin. All right. It's actually is a samples, number of samples. So right now it already get 3,800 readings. Okay. So y-axis is the voltage. So unless you are able to read from the graph from these serial plotters for the numbers. So for example, here, the red color, what is the voltage for this red color now? Actually, we have no idea, right? Because you can see the trend is decreasing or increasing, but you cannot get the absolute readings about the voltage. So that's why I will say that this serial plotters basically is just for you to have a very quick look about the changes of the voltage. But if let's say you want to do the calibration and get the exact readings, probably you need to use these serial monitors. So serial monitors, you are going to get the readings exact numbers. So here is 0.58 volt. So now 0.21 volt, and then 1.11 volt, 1.77 volt. Okay? Answer your question?
Yes, doctor. Thank you.
Okay. All right. So any more questions? Any more? Right. Okay. Abdul Rahman Abba actually asked, can you show how to connect the op-amp and battery to the Arduino? How to connect op-amp and battery to the Arduino? Okay. Yeah. This is actually a very good question. Okay. All right, so I think I'll just this Tinkercad. I'll just use a Tinkercad to illustrate the. So this one, most probably, I think I'll just open out previously circuits that I have already made. Right. Okay, this is a differential amplifier. So you can see that this is a differential amplifier, right? Everyone could see the circuit?
Yes, doctor.
Okay. So now instead of using this multimeter, most probably I'll just try to measure it using the Arduino Uno. Okay, so I'll just drag Arduino Uno over here. And then I'm going to get the readings for this one is okay, this one is voltage follower, and then I get yeah, so that is the output. So in that case, I'm going to measure the output for this purple. Right, so what I need to do is I just get this line and then put it in the A0. Okay, so this is a purple line, a pink. Okay, and now if let's say I straight away do the measurement like this, maybe I'll just I just try it out with this. Let's see, is it going to be able to detect it? I'm not really sure, but supposedly it shouldn't be. All right, so I'm going to get the readings from the example. Okay, so read analog voltage example. Okay, give me a moment. Let me open out the Arduino IDE again. Okay. All right, so this is the code that I have uploaded. I mean the down copy from the example. I only get the readings at the A0, and let's see. Now start simulation, and let's see, can I get any readings? Okay, so you are going to get, you can see that it's a 0 volt. All right, and therefore, let's say right now I change, all right, so you can see that right now, supposedly when I'm changing this to 1.19, 4.07 minus 1.2, so I get 2.8. Supposedly I should get a 2.8, but the readings at the serial monitors over here is actually 0 volt. The main reason is that you can see that this Arduino Uno, the electricity is coming from the output of this op-amp. It enters into the Arduino Uno. But then later on, how can it return? We know that the power supplies, this is a battery power supply, right? So electricity comes to here and then it flows into the voltage followers and then later on comes to here. It goes to the multimeters and then it goes back to the ground and then the battery ground. So that's why this forms a complete, a complete cycle. Starting from the power supply and then it goes through all the components and then eventually it goes back to the ground. It's a complete loop. So that's why multimeters is able to give you any kind of readings. But for the Arduino Uno, you can see that the electricity comes from the batteries and then go to the voltage followers and then goes into the differential amplifier output from it. And then it enters into the Arduino Uno board. Then later on, it goes to nowhere. It is not going to return back to the battery. So that's why this is the readings over here is just keep on giving you 0. All right. So what you need to do is to common ground it. So for the common ground, basically common ground is 0. So this 0 is so I just need to connect it to here. There is a common ground. Okay, the green to green, and now I can start the simulation again. Okay, and then all right, coding, and you can see that after I do the common ground, now I am going to get the voltage readings of 2.87. Okay, which is quite close to this 2.88. All right, and if I rotate the potentiometers over here, so I have 1.2 minus 1.68, I get negative 2.88. This is something I think is, which is not very correct now, because supposedly Arduino Uno could only give you positive readings. Okay, so it means that this one I think is a bug in this simulation. It shouldn't be negative. So if it is negative, then it will actually like saturated in the real Arduino Uno. Right, so now I'm going to get a 3.83 readings. Okay, everyone? You understand why I'm trying to convey the message over here? Everyone clear?
Yes, sir.
Okay, clear? So this is only the things that you need to remember when you are using the Arduino. Okay, Arduino, it needs to be common ground. So the ground over the Arduino needs to be grounded with this whole system. If you are using multimeters, then you need not to be worried about it. Basically, multimeter is just like here, over here. You just need to connect it to the one of the pin to the common ground, and then another goes to the positions that you want to measure. That's all. So using multimeters, of course, will make your life easier. But Uno, you are able to measure at three different sites. For example, over here, I can actually measure all these three positions as well. Right, so just by using the code that I'm using just now, I can straight away measure 3 at the same time, input, output. Okay. All right. Any questions?
So, Doctor, we don't need to have a power source to the Arduino, is that?
Power source to the Arduino will be coming from the computer USB. You still remember over here?
Okay.
yeah, it needs to connect to the USB in order to do the program. So once you plug in the USB, this is directly already powered up by 5 volt. Okay. It depends on you. If let's say you want to make your life easier, then forget about Uno. You just get a multimeters. But if let's say you want to save the spendings, because this Arduino Uno can be used later on in the in the latest mechatronics, right? So in that case, most probably you can get the Uno. Okay, but multimeters, I would say that if possible, by right you should get one multimeter as well. Okay, even in the mechatronics, this could make your later on when you develop your mechatronic systems, you want to detect whether are there any short circuit or not, or you want to measure what is the voltage to do the debugging, then most probably even in the mechatronic you also need a multimeter. So I leave the decision to you whether you want to use a multimeters or Arduino Uno. But for this project, I would say that using multimeters alone is already enough. Okay, Arduino Uno is also okay. You can use it. All right. So this is your own decisions. You want to use which one? Okay. Any more questions? All right. If no questions, then I think that's all for the lecture today. I'm not going to go into the lecture slides, right? Because I'm worried that some of our friends maybe they are affected by the flood, so that's why they cannot join this session. So I'm not going to go through the slide lah. But this one, what I have discussed this morning, most probably this information you can share with the friends who have not come to these lectures. All right, so before I end the session, make sure you slide in the attendance. I've already put the attendance at the chat, so you may just slide in there. Okay, so if you don't have any questions, then you are free to go. Okay, so that's all for the lecture today. If you have any question, you can also ask me right now. Okay.
Thank you, Doctor. I'll probably have more questions next week.
Yeah, I'm going to have this kind of discussion also from time to time, right? But next week, I think the lectures on Mondays, I need to cancel it because I'm going for a trip from Sunday until Monday. Okay, so I'm not going to have lectures on these 2 days. All right, so but the lecture on Thursday, we are going to have meetings also lah. Okay, I'm going to inform you this through the WhatsApp as well. So for the news about the test one, I need to say right now, the lecturer has not assessed the question yet. Okay, so no news at all. Okay, sorry about that. Okay, any more questions? So no questions, then okay, that's all. See you all next week, next Thursday.